Hi, this is Sivanagi Reddy and we are going to see the third part of very short answers question from semiconductors and semiconducting devices. So the first question is explain the formation of PN junction diode. PN junction diode is formed by bringing together P-type N-type semiconducting materials. When these two N-type P-type materials are brought together, the excess of electrons from N-type material diffuse across the junction into the P-type material, filling some holes. This creates the dip region. So here we can see from here to here, this is the depletion region at the junction where there are no free charges. The resulting structure act as a rectifier. So this allows the current to flow in only one direction but not the other way. Then what is the difference between direct and indirect band gap semiconductor? When we observe the graph carefully, the diagram E versus K, energy versus propagation constant. In this we have two bands, material valency band and conduction band. Top of the valency band and the lower edge of the conduction band lies on the same K value. That is a direct band gap semiconductor. When come to indirect band gap semiconductors, the K value is different for conduction band and valency band. That's the main difference. And based on this one, the applications will change. These direct band gap materials are compound semiconductors. Compound semiconductors means gallium arsenide, indium phosphide. These are used in the manufacturing of LEDs and other semiconducting devices, whereas for direct band gap semiconductors, they are pure germanium, silicon. These are mostly used for solar cell. The lifetime of charge carriers is very less, lifetime of charge carriers is very more. Next question is applications of a solar cell. What do you mean by solar cell? Solar cell is a semiconducting device which converts light energy into electrical energy, and there is a many type of applications for it, for generating the electricity in residential and commercial buildings and powering the satellites and other spacecrafts. That's the main applications. Then providing the electricity to remote locations where traditional power sources are not available, and for charging the batteries for portable electronic devices. And next one is list out the applications of LED. LED stands for light emitting diode, which will convert electrical energy to light energy, and it has a very wide range of applications. And lighting for homes, office and public spaces present days we are using, and displays for electronic devices such as smartphones, televisions, automotive lighting such as headlights and brake lights. So for lighting purpose mainly we use, and signals and advertising displays also we use the light emitting diode. Light emitting diodes are operated in basically forward bias. Next one is what is a Hall effect. Hall effect is a physical phenomena that describes the production of voltage difference across a conductor or semiconductor material when it is placed in a magnetic field perpendicular to the direction of current flow. So whenever we keep a semiconductor in a magnetic field and electric field which are perpendicular to each other, the other direction voltage will be generated due to the separation of the charge carriers. Those are nothing but the electrons, which gives rise to the voltage. That's what we call Hall voltage, and the phenomena what we call is a Hall effect. Then what is the difference between intrinsic, extrinsic semiconductors? Intrinsic, extrinsic semiconductors, basically intrinsic semiconductor is a pure form, and whenever we dope with trivalent or pentavalent impurities to pure semiconductor, we will get a extrinsic semiconductors. In intrinsic semiconductors, holes and electrons are equal in number, whereas in N-type semiconductors, free electrons are more. In P-type semiconductors, holes are more. Then Fermi level lies in between the valency band and conduction band. So this is the Fermi level. Then Fermi level lies near the valency band in P-type semiconductors and near conduction band in N-type semiconductor. Then ratio of majority and minority carriers is unit, but the ratio will be different for extrinsic semiconductor. Then we will go for actual the difference between N-type, P-type semiconductors. So in a N-type semiconductor, it is a donor type. P-type semiconductor, it is an acceptor type. In this, if we take pure semiconductor and if we do pentavalent, then we will get N-type. N-type stands for excess of electrons we have. Whenever we take a pure semiconductors and dope with the trivalent, we will get a P-type semiconductors where holes are majority. Donor level lies close to the bottom of the conduction band and acceptor level lies close to the top of valency band. And the below images shows the perfect crystal N-type and P-type wherever these AS and B are impurities added to the system and the double dots, whatever we are saying, electrons. All the best for your exam. Signing off, Dr. Sivanagi Reddy. Jai Hind.